Hello, my name is Mario Ramirez and my partner is Omar Palacios. We're going to talk about working with the bus converter. The objective of this converter is to give output the high tension than the source DC outputs. Functioning. Generally, the bus conversion has the following this kind. When the transition of the inductor is found a situation where don't must allow the arrow change of the current. So, for the counter, this situation is mostly shared as electric energy accumulated of anyway. Now, in the low voltage, we have the sum of voltage of the source and that the load voltage and higher than the input voltage. At the same time, the diode path of conduct that allow that the capacitor is charging. When the transition or the MOSFET transition is working like a switch, when the transition conduct input the circuit of capacitor at the load. So the current is following also the inductor. Now the current only following the inductor. This make that the inductor accumulate electric energy in his electric fire. The loops. When the cycle is repeat the transition conduct again, for both of that the inductor is charging again. The capacitor keeps the level of the voltage in the load. That to the capacitor is opposite to the average charge of the voltage, and that is principal work of the capacitor in this circuit, and has become a load. The voltage gain in the load will depend on the frequencies of the pulse and high duty cycle, where the duty cycle is equal to the time where the pulsar is high device. For the period of the square wave, where the period is equal to the sum of the high pulsars and the low pulse time. Energy conservation. But there must be a limit, see from the point of the view of power. We must be very clear that in the input power is equal to the output power plus 2 loss in the passive element, which is consequence of the conservation of energy. In the boost converter, the output voltage would regrab the point voltage analogous of the operation of the transformer. So, if we have 12 volts and 2 amp supply available, and the output voltage is double, then the output current moves in the half of the point, the input. Current in the inductor. Another fact to consider of the characteristic of the current that crosses that inductor we can analyze in the fundamental law of the inductor that relate of the voltage and the current.
I will talk about the benefits of use boost converter compared to other topologies. Bus regulator. It's necessary to say that each type of regulation has a specific function for which it was designed. Talking about bus regulator, it takes a DC input voltage and produces a DC output voltage that is higher in value than the input voltage but with the same polarity. For other hand, the buck regulator, it is used to down convert a DC voltage to a lower DC voltage with the same polarity. The buck bus regulator. The buck bus regulator, that is an important regulator, takes a DC input voltage and produces a DC output voltage that have an opposite polarity respect to the input. Besides, the negative output can be either larger and smaller than in a magnitude than the input voltage. Flyback regulator. Flyback regulator is one of most versatile of all of the types. It operates in either continuous mode or discontinuous mode. This topology allows to the designer to create one or more output voltage, some of which may be opposite in polarity. Finally, push-pull converter. Push-pull converter have a disadvantage compared to other topologies. This kind of regulator requires very good matching of the switch transistor to prevent an equal on time. This will result in saturation of the transformer core. Some application of the bus converter are they are used in regulated DC power supplies. Low power bus converters are used in portable device application, and it is used as a switching regulator circuit in highly efficient white LED drives.